Okay, good morning, everybody. I'm happy to see so many of you, and thank you for last night. It was a wonderful dinner, so thank you to the organizer. So I will do my best replacing Pierre and talk about the new project that we got from the Act 3 program, which is called Return. So let's see how there is, how do I proceed here? Because I don't have a clicker, and this one is this one. No, there it. Oh, that was the last one.
I think we can go.
Oh, so these are the arrows. Oh, thank you. Yeah.
Quick preview.
Okay, that was quick. So, okay, so yeah, so Return is an Act 3 project. So it's financed by a national funding agency, and like we talked yesterday about depleted reservoirs are a good source for CO2 storage, but they have their challenges, but also the advantages. So that is the reason why we established Return, in order to try to make it more safe and cost efficient for long-term CO2 storage. And especially when we do have depleted reservoirs, the pore pressure is less than originally. And this, when you want to inject high pressure, dense CO2 phase into the subsurface, which is lower pressure, that will generate cooling and also potential freezing of the wellbore itself and near region. And these challenges needs to be overcome. And that is what we are addressing in this project. So we just started, so unfortunately I don't have many results to present. And it's quite a large project with 7.5 million euros. It is a quite extensive consortium. We have 3 universities and 3 research institutes, and then also up to 12 industry partners. And the industry partners are very active also in the project, contributing with in-kind or with work. Okay, so as we talked about yesterday about the depleted reservoir, and we also had this nice presentation from Aramis project that they are starting. So what the advantage of going into depleted reservoirs is that we have data and also knowledge about how the reservoir behave, what we gain through the production of oil and gas. And also that the pore pressure is lower is an advantage, because then you have can pressurize or you inject, and then you're not so scared about crossing the pressure limits of your reservoir. But the drawbacks is what I mentioned is the cooling effects, the Joule-Thomson effect. So we have these, both the cooling and also thermal stresses that can cause fracturing around the wellbore. And of course, the depletion process is not necessarily uniform, especially if you have heterogeneous reservoirs, and then you will have stress concentration generated due to the depletion. Okay, so the expected impact and key targets of the project is to enable what we call cold injection, because the way, what we are doing now to mitigate the problems is to heat the CO2 and then also inject the CO2 in the gaseous phase. That requires more wells, and also this is energy consumption and expensive. So that's why we would like what we call cold injection, in order to keep, doesn't need to heat the CO2 before we inject it. And this is limiting, when we have cold injection, the operational phase that you can have when you do your injection. So that's what we are looking into. And also, in general, hoping that these altogether will reduce the cost of CO2 storage, since we can reuse some of the infrastructure, and the qualification cost, that means the data collection, and also for looking into the reservoir behavior, is less than an aquifer. And as all the ACT projects in general, and I would like to say perhaps all CCS projects now, they have a strong focus on communication and the social acceptance of CO2 storage. Okay, so the project structure shows here the technical aspects. So we are looking into both experimental and numerical modeling. And what we focus on is to have on the understanding of how the CO2 flows down the well and into the depleted reservoir. And then we have the special focus on the Joule-Thomson cooling effect, the phase transformation, and also the pressure and temperature cycling that will happen, and how this temperature and pressure cycling affects the wellbore itself, but also the reservoir rock and also the sealing formation. So this is, the work package 1, which is not written here, is the administration. So number 2 is coupled to the well reservoir flow modeling, so seeing how when the CO2 flows down the well and how it goes into the reservoir, and that is naturally also related to injectivity. That's the same also for the new well processes and the well integrity issues. And then all these 3 activities are wrapped up in order to see how it will be possible to do cold injection. So, so what we would like as an output of the project is to have advanced numerical models that are able to accurately predict the thermo-hydro-mechanical response of the wellbore reservoir caprock system. So it's quite an ambitious target. And for doing this, the numerical models will be based on physical processes that we observe, and it will be calibrated and tested through what we do for the realistic in situ conditions that we have involved 2 field station laboratories in the work. So, and here, that's what's done so far. So we will use, as mentioned yesterday, also quickly mention the Svelvik CO2 field lab that we have in Norway with SINTEF. And even before the project started, we completed some fiber optics installations, because that was also to cooperate and to have an alliance with the Act 2 project, Digimon, that at that time was doing experiments at the site, and they really needed the same type of fibers that we were going to use in return. So that's why we accelerated and implemented that. And then, sorry. And then we have an injection well, which is not instrumented. So we would like to, as I mentioned, to install fibers, and in order to do that, we have to remove the packer and the older system and to reinstall. And before we're doing that, we would like to know how it looks like down in the well in order to not, make the packer stuck or something that we will lose our well. So the photograph here is from this autumn, where we are just inspecting. So we have a camera so that we go down and to see that the conditions downhole are as expected before we remove the packer and install the fibers. And then also the field research station in Canada, they are also part of the project. So the 2 field labs are complementary in that way, because in Canada have deeper wells, and you will more easily see the exact phase transition when you do the injections there. So they have also started to upgrade with pressure and temperature sensors in their tubing. So that's the activity then there. And then you have, so the most we have done experimental work, and so we have Shell has been doing the CO2 exposure test on a outcrop Munkle shale in order to see how the CO2 is affecting the mechanical properties of the material. And they could clearly see that there was a strength reduction when you are in contact with CO2. Then we have the University of Freiburg that has looked into how CO2 hydrate forms in Bentheimer sandstone. And you can see that actually is happening. So, and then they have, ENI has also looked into salt participation tests, but they actually saw less effect on the permeability than expected. So these are just initial tests that will be used to calibrate and to look into the models. But as you see here, we have done, the tests have been done will be done on different partners. But overall, the best is to use that all the partners test the same type of material. So that's why you can see the photographs from earlier this year that they were going together with Leeds University and sampled the Whitby shales that you can see. And there's also sandstone from a French quarry. I'm not quite sure. I think it's Grès de Vosges, but I'm not quite 100% sure. That will be used so that all the experiments will use the same material, and it's easier to compare what's happening in the different labs. And so that is, I think my timing is quite okay. Good, good. So the conclusions is that we have, this is a photograph for the startup. They had a kickoff this summer. And the cooperation between both the research organizations, the university, and the industry is working very well. We have a web page, as all the ACT projects have. So for more details and what's happening there, you can go into the Return ACT EU webpage. And the activity that would happen later this year is that we will start out the geomechanical testing and also the well integrity testing. And as you can see, that will be done by several partners in order to compare the complementary tests. And also the numerical modeling will start. And then there is planned to have a common workshop with the other ACT projects. So that will be announced soon. So I just encourage you, if you are in general interested in the ACT project, but also for this return, just go and visit the webpage. So I guess that was what I had.